Hello grade 7s, welcome to today's natural science video lesson. I hope you all are doing well. And today we'll be going over quite an easy section, properties of metals, semi-metals and non-metals. And this can be found on page 112 of the textbook. So this section being really easy, you can just read through it quite nicely, and you don't even really need me, I think, to explain things. But what I've done here is made a short summary of everything. So we've seen the idea of metals, semi-metals and non-metals before when we looked at the periodic table, and we saw that it was divided into these three categories. And in this lesson, we'll be going over the properties of each category. So we're going to start with metals. Metals are ductile, and that means that they can be stretched. So now you might say, but Kels, in a previous video you said that metals couldn't be stretched. When we looked at properties of strength, you had the copper wire and it couldn't be stretched, and you said it had good tensile strength. And now in this video you're saying that it can be stretched. So what's going on? Well, the reason these metals can be stretched is when heat is applied to them to make them soft. And then they can be stretched easily into these long, thin shapes. Metals are also malleable, and that's a fancy word for it can be bent easily. Metals are also good conductors of heat and electricity. So, for example, our pots and pans are made of metals. It allows an even spread of heat through the base of the pot, and it allows the food to be cooked through. For conductors of electricity, most wiring is made out of metal. Metals are also shiny in appearance. So for example, you get the magpie, which is attracted to shiny things, and it steals people's coins and jewelry to try and beautify its nest. Next, we have the category non-metals. And they have the properties of being rigid or brittle. Rigid means it can't be bent easily. So for example, this plastic pen is rigid. Brittle means that it can easily be broken up into pieces. So metal, if you try and break it into pieces, it's not that easy. It stretches, it bends and stuff. You actually have to cut the metal. Non-metals are also poor conductors of heat and electricity. So when something is a poor conductor, we can refer to it as an insulator. So all the wiring in our houses is covered by this plastic sheathing, and that prevents the electricity from conducting. So if you hold the wire, you don't get shocked. As good heat insulators, we can think of our blanket, which keeps us warm. It traps in the heat and prevents the cold from getting in. So lastly, non-metals are dull in appearance. So dull is the opposite of shiny, and you can think of a dull cardboard box. So next we move on to the semi-metals. So if you look at the category semi-metals in the periodic table, you'll see that it lies directly between the metals and non-metals. So this is not by design, just to make the table more visually appealing. It's really like that because of the construction of the atoms. So the atoms of semi-metals lie between the atoms of the non-metals and the atoms of the metals. And that means that they share the properties of both. So semi-metals have properties of both metals and non-metals. So the classic example that we're going to look at is silicon. Silicon has the chemical symbol Si, and you can find this in the textbook. If you look at the picture of silicon, you'll see that it's shiny, so it shares a property of the metals. Silicon can also partially conduct electricity, and when we say partially conduct, we mean it's a semiconductor. So that's another property of the metals. However, silicon is brittle, so it shares a property of the non-metals, and also silicon is a poor conductor of heat, another property of the non-metals. So next, I just wanted to talk about some further properties of the metals and non-metals. And this is not in the textbook, it's purely for enrichment and a deeper understanding. So even though these elements are grouped in the same categories, there are quite significant differences between them. So for example, gold is a much better conductor of electricity than steel. And you'll find gold in certain very fine circuitry that you get in computer chips. Gold also has a much lower melting point than iron. So having a very low melting point allows the gold to be shaped very easily and make fine jewelry, those fine designs. Next, we have mercury. Mercury is the only liquid metal. So all other metals are solid at room temperature. And you'll find mercury in the old school thermometers. So when the temperature goes up, the mercury expands and the level rises. When the temperature drops, the mercury shrinks and the level decreases. So for the non-metals, I wanted to talk specifically about graphite. Graphite is actually a special arrangement of carbon, and it's commonly used in pencils. So when you write with your pencil, the graphite splits into pieces and it makes marks on the paper. So graphite is one of the only non-metals that can conduct electricity. And you must just remember, for every rule that we have, there's always exceptions without exception. So next, I just wanted to do an example with you guys. So the example I've chosen is activity 5 on page 115. And what we're doing here is comparing the properties of 3 different metals: iron, aluminium, and copper. So I've got an iron screw, the copper wire, and an aluminium can. So the first property we're going to look at is the appearance. So the iron screw is like a dark silver in color, aluminium is silvery, and copper is an orange-brown color. Next, we're going to look at magnetism. So if we check, the copper is not magnetic, the aluminium is not magnetic, however, the iron is magnetic. So I've indicated this here with a tick for the iron and 2 crosses for aluminium and copper. Next, for electrical conductivity, you can see a little picture in the textbook showing the light bulb and how brightly it shines when there's a circuit with each of these metals. So I can't really show you experimentally, I don't have a light bulb on me, but in terms of conductivity, iron and aluminium are both conductors, but they're not very good. Copper is the best conductor. So I've indicated this with 3 ticks and 1 tick for each of the other 2. So you'll notice in real life as well, like all the wiring in houses is made of copper. Lastly, we're going to talk about bend. So the iron is the least flexible. That's why it's used to make things like screws and nails. Aluminium is a little bit flexible, but it's also relatively strong. So that's why it's used in making constructions like cans and also in larger constructions like airplanes. Lastly, copper is very weak. It's very easy to bend and very flexible, and this is why it's also used in wiring. So that concludes today's video lesson. I hope you guys understood and everything was clear. And yeah, thanks for watching. I'll catch you guys in the week. Take care.